Hello everyone, I am Sandeep. I am here to discuss about expert systems and its application. Artificial intelligence is a piece of software that simulates the behavior and the judgment of human or an organization that has expert in a particular domain is known as an expert system. It does this by acquiring relevant knowledge from its knowledge base and interpreting it according to the user's problem. The data in the knowledge base is added by humans that are expert in a particular domain, and this software is used by a non-expert user to acquire some information. It is widely used in many areas such as medical diagnosis, accounting, coding, games, etc. An expert system is a AI software that uses knowledge stored in a knowledge base to solve problems that would usually require a human expert, thus preserving a human expert knowledge in its own base. They can advise users as well as provide explanation to them about how they reached a particular conclusion or advice. Knowledge engineering is the term used to define the process of building an expert system, and its practitioners are called knowledge engineers. The primary role of a knowledge engineer is to make sure that the computer possesses all the knowledge required to solve a problem. The knowledge engineer must choose one or more forms in which to represent the required knowledge as a symbolic pattern in the memory of the computer. Let us deal with an example. There are many examples of an expert system. Some of them are given below. MYCIN, one of the earliest expert systems based on the backward chaining, it can identify various bacteria that can cause severe infections and can also recommend drugs based on the person's weight. Next one is Dendral. It was an artificial intelligence-based expert system used for chemical analysis. It used a substance spectrographic data to predict its molecular structure. Next one is R1/XCON. It could select specific software to generate a computer system wished by the user. Next one is TXDES. It could easily determine the type and the degree of the lung cancer in a patient based on the data. Next one is CADET. It is a clinical support system that could identify cancer in its early stages in the patients. Next one is DXplain. It was also a clinical support system that could suggest a variety of diseases based on the findings of the doctor. Components of an expert system is given below. Expert systems are classified by their knowledge base, inference engine, knowledge acquisition and learning module, user interface, etc. Let us understand knowledge base. The knowledge base represents facts and rules. It consists of knowledge in a particular domain, as well as the rules to solve a problem, procedures, and intrinsic data relevant to the domain. Inference engine. The function of the inference engine is to fetch the relevant knowledge from the knowledge base, interpret it, and find a solution relevant to the user's problem. The inference engine acquires the rules from its knowledge base and applies them to known facts to infer new facts. Inference engines can also include an explanation and debugging abilities. Let us understand about knowledge acquisition and learning model. The function of this component is to allow the expert system to acquire more and more knowledge from various sources and store it in the knowledge base. Let us understand about user interface. This model makes it possible for a non-expert user to interact with the expert system and find a solution to the problem. Next one is explanation module. This module helps the expert system to give the users an explanation about how the expert system reached a particular conclusion. The inference engine generally uses two strategies for acquiring knowledge from the knowledge base, namely forward chaining and backward chaining. Let us understand about forward chaining. Forward chaining is a strategy process used by the expert system to answer the question, what will happen next? This strategy is mostly used for managing tasks like creating a conclusion, result, or effect. Example, prediction or share market movement. Now let us understand about backward chaining. Backward chaining is a strategy used by the expert system to answer the questions why this has happened. This strategy is mostly used to find out the root cause or the reason behind it, considering what has already happened. Example, diagnosis of stomach pain, blood cancer, or dengue, etc. Now let us understand about characteristics of an expert system. Human experts are perishable, but an expert system is permanent. It helps to distribute the expertise of a human. One expert system may contain knowledge from more than one human experts, thus making the solutions more efficient. It decreases the cost of consulting an expert for various domains such as medical diagnosis. They use a knowledge base and inference engine. Expert system can solve complex problems by deducing new facts through existing facts of knowledge, represented mostly as if-then rules rather than through conventional procedural code. Expert systems were among the first truly successful forms of artificial intelligence software. Let us understand the limitations about expert systems. They do not have human-like decision-making power, cannot possess human capabilities, cannot produce correct results from less amount of knowledge, and requires excessive training. Let us understand their advantages and disadvantages. For advantages, their accessibility is at low cost, and they have fast responses, not affected by emotions unlike humans, lower error rate, capable of explaining how they reached a solution, and the disadvantages of them that is the expert system has no emotions. Common sense is the main issue of the expert system. It has developed for a specific domain. It needs to be updated manually. It does not learn itself, not capable to explain the logic behind the decision. The applications of expert systems. Different types of medical diagnosis like internet medicine, blood diseases, and so on. Diagnosis of the complex electronic and electromechanical system. Diagnosis of a software development project. Planning experiment in biology, chemistry, and molecular genetics. Forecasting crop damage. Diagnosis of diesel electric locomotive system. Identification of chemical compound structure. Scheduling the customer order, computer resource, and various manufacturing tasks. Assessment of geologic structure of deep locks. Assessment of space structure through satellite and robot. The design of VLSI system. Teaching students specialized tasks. Assessment of log using civil case. Evaluation of product liability, etc. Expert system has evolved so much that they have started various debates about the fate of humanity in the face of such intelligence, with authors such as Nick Bostrom, who is a professor of philosophy at Oxford University, wondering if computing power has transcended our ability to control it. Thank you.